Hello class, this is a video tutorial on indices, and in this video we'll be exploring prime factorizations and factor trees. Without explaining too much, I'm going to show you through an example as to how to do this. Let's take a look first at factor trees. What a factor tree is that it breaks down a number into factors. Let's take a look at first this number here. Let's take a look at the number 180. And what we do from this number is we begin dividing it into we begin dividing it by the numbers 2, 3, 5, 7 and onwards. The numbers that the reason why we're picking these numbers is because they are prime factors. They are prime numbers. So I'm going to list the numbers here. So the numbers we divide by are 2, 3, 5, 7. It's mainly the 4 that we're going to encounter often. And maybe we'll have to do the numbers 11, 13, and that's pretty much it. We won't go any larger than that there. So let's begin. So all we do now is we divide it, going from the smallest number that we can see to the largest. So 180 can be divided by 2. We know that because the last digit is 0. So we can divide this by 2. And we branch it off like this. 2 times what gets me to 180? Well, since I know that 2 times 9 is 18, 2 times 90 is 180. And then all we do is from this number now is we keep dividing it by the number 2 until we can no longer do it. So let's test it again. Can we divide 90 divided by 2? So let's go down this way. 2 times what gets me to 90? And here's where our long division can help. Just on a little empty space here, we're going to do 2 into 90. 2 times what gets me to 9 as close as we can? Well, I know 2 times 4 gets me very close. 2 times 4 is 8. 9 minus 8 is 1. Carry the 0 down like that. 2 goes into 10 5 times. So 45 is our number there. Gives me 45. Now, we know that 45 can no longer be divided by 2 because it is no longer an even number. So let's test the number 5. Oh, 5 will definitely work because the last number there is 5. 5 times what gets me to 45? Well, 5 times 9 gets me to 45. And what we do is we break down further and further until we can no longer keep going. Let's take a look at the number 9. Well, 9 can be divided by 3. So I know 3 times 3 gets me to 9. So now we're going to circle the prime factors. We're going to write them out in a row, in ascending order. 2 times 2 times, we could do 5, but we'll do 3 first because it's smaller than 5. So 2 times 2 times 3 times 3 times 5. And using index notation, these two numbers is 2 times 2. Since it's 2 repeated twice in multiplication, that is 2 squared times 3 times 3 is 3 to the power of 2. And finally, 5 is by itself, so it's just times 5. So this here is a prime factorization of the number 180. And this here is a factor tree for the number 180. Let's do this process again one more time. The number 168. Here we go. 168 is divisible by 2 because that number 8 can be divided by 2. So 2. That's a fairly large number to do it, so we'll do 2 into 168. 2 into 1 we cannot do. 2 into 16, well, I know that 2 times 8 is 16, but if we use 16 like this, minus, we get a 0. And all we need to focus now on is the number 8. 2 into 8, 8 divided by 2 is equal to 4. So that number there is 84. Breaking this further down again, I know 2 can work. And this is a fairly cool little trick we can do. 8 divided by 2 is 4. 4 divided by 2 is 2. This can break down again by the number 2. Let's divide this again by the number 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 21 is no longer divisible by 2. Let's test the number 3. 3 times what gets me to 21? Well, I know 3 times 7 is equal to 21. Now let's underline or circle our prime factors, the ones at the very bottom. That will give us 2 times 2, 1, 2, 3, times 2, times 3, times 7. That's 1, 2, 3 lots of 2. 2 to the power of 3, times 3 by itself, times 7 by itself. So that's a brief overview on how to do prime factorizations from a factor tree. Best of luck.